Okay, for those of you who missed class when we went over the recap and warm-up of 5.2b lesson with altitudes, here is your video that we did in class. The warm-up asks you to go ahead and, based on these markings, determine whether segment AB is a median, angle bisector, perpendicular bisector, or altitude. So when we look at these, we're looking at those specific markings that we talked about on the first day of the chapter. So on number 1, what we're going to see here is the marking that I see is this 90-degree angle being perpendicular. So that means that segment AB is perpendicular to the opposite side. So we're going to come out of the vertex and create perpendicular on the other side. So what's happening is segment AB is perpendicular through point A, meaning we have our altitude. Okay, that 90-degree perpendicular, that's all we're looking for with altitude, is only the 90-degree angle. On number 2, what I'm noticing here is with segment AB, I'm noticing that segment AB it cuts angle A in half, okay, or into 2 congruent angles. So right here, where I have here and here my 2 markings, this is going to be picture perfect example of your angle bisector. On number 3, segment AB, and the thing I'm noticing here are some congruent markings down here. That tells me that this side over here on the triangle has been bisected, it's been cut in half by this point, point A. So I have a midpoint. So segment AB is going from the midpoint to the vertex on the opposite side. So here I have my midpoint and it's going to the vertex. So with my 2 congruent markings, I have come to the conclusion that this is your picture perfect example of a median. All that we have with a median is that midpoint creating 2 congruent segments of a side. Now with the next section, what we wanted to do was using, starting from vertex O, we want to draw the altitude or the height of the triangle. Remembering that the height is not always inside of the triangle. So here with point O, our goal with altitude is going to be, we want a right angle. We want it to be perpendicular. Okay? So we start at point O on the first triangle and we just want to go straight down, creating a 90-degree angle. So therefore, we have now drawn an altitude that is perpendicular with side PR or segment PR. The second one, we'll start at O like it's asking us to, altitude from vertex O. We're going to go straight down, and we're noticing on the first one it looked like it was going halfway, so we probably have an isosceles triangle over here. Here, our 90-degree angle, we're not going to a midpoint. We also don't know that this first triangle is an isosceles because we didn't mark anything else. All we want is altitude. Altitude is only that perpendicular right angle. Okay? Then our last one here, we're going from vertex O. Well, if we want to go perpendicular, we're going to have to go straight down. And when we go straight down, we're not going to run into that side. So, as we discussed in the video, we're going to have to extend this side so we can create that 90-degree angle. So on this triangle, the altitude is actually outside of the triangle. Hence why it says the altitude is not always inside of the triangle. Now what I did at the very bottom was to make it kind of more clear for me to see. I want you guys to see what I did. I took my highlighter and I highlighted what kind of triangle it is, and then I highlighted the sides of the triangle so that I could see here where my triangle is and where my 3 altitudes are and where my orthocenter will be, seeing clearly that my orthocenter is inside the triangle. With my right triangle, again, highlighted all 3 sides, and then I outlined with my orange pen each of the 3 altitudes, seeing that your orthocenter is on the triangle. It's on one of the vertices. The biggest reason I wanted to highlight was because when you have an obtuse triangle, I want you guys to see what I've highlighted. I've highlighted, again, the 3 sides of the triangle. That way I don't get confused with all the lines. The sides were more bold and they were darker. So I was able to see now with all 3 of my altitudes. I think I forgot to trace this one. Okay, but with our altitudes here, we've got our altitudes, there we go, leading to the fact that we are now outside of the triangle. Okay, so I just wanted to let you guys see with the highlighted of the triangle so you could see a little more clearly, especially right here with our obtuse triangle. Now, with that being said, we'll go back to our first page here and we'll go ahead and fill in our information based on the point of concurrency. So here, we're looking at our altitude, okay, and our point of concurrency with an altitude. I'm sorry, we're not on, well, that's angle bisector. Down here on altitude, so Mapaseco works, we had to put altitude at the bottom. So with altitude, remembering here in our previous notes, we have an orthocenter. That's going to be where our point of, that's going to be the name of our point of concurrency where our 3 lines intersect. So our little bullet point over here, this is going to be a point. Orthocenter is where 3 altitudes intersect. And again, as we saw in those bottom 3 triangles on the notes, we see that depending on what kind of triangle we have, your orthocenter could be in different locations. On our acute triangle, we saw that the orthocenter was inside the triangle. We saw that on the right triangle, it was on a vertex of a right angle. And our obtuse triangle, we saw this orthocenter was outside the triangle. So with our 3 triangles here, we're going to go ahead and draw our 3 altitudes. We're going to start here. This is going to be an acute triangle. So we make sure this matches up. We have our acute triangle. We're going to draw our different altitudes. So we're going to start at this top vertex. I'm going to go straight down, creating a 90-degree angle. Now the altitudes, I like to turn the triangles, rotate them so that I can see, so I make sure that I'm going perpendicularly. So if I turn, I look at this vertex up here. Whenever I go straight down perpendicularly, it's almost like it's a right triangle. Okay? And so here's my next altitude. And then let's go ahead and face it this way. We're going to take that vertex and go straight down, and it should go straight. It should intersect exactly with our other 2 altitudes. Okay? Creating our orthocenter right here. So let's take a look at the right triangle. This is going to be our right triangle over here, as you should have seen in the video as well as with the bottom of the notes. Our right triangle, we're going to go from this, off the screen. We're going to go from this vertex right here straight vertically down, create a 90-degree angle. I'm going to rotate it this way, and I'm going to go to this vertex, and I'm going to make sure I go straight down perpendicularly, and I wind up with that same 90-degree angle. So we have our legs as our altitudes of a right triangle. Then I have one more vertex I haven't gone through yet, and that's going to be where the 90-degree angle is. So then when I take that straight down to form my 90-degree angle, we're going to notice that all 3 of these intersect right here. And there's my orthocenter. The last triangle we have here is going to be our obtuse triangle. So here's our obtuse triangle. And we're going to go, each one of these, we're going to go straight down. And we're going to notice here, taking our, let me switch my colors up. We're going to go straight down perpendicularly to create our altitude right here. And then we go to our next vertex. We'll go over here to this guy. What's going to end up happening is with this one, if we extend this kind of like here, this is because this is an obtuse angle, this guy's going to be outside of the triangle also. Okay, so I need you guys to see the difference there. All right, we're still going outside. It's not going right here. Okay, if we line this up right here, I try to get it as straight as possible on my camera. If we take this vertex, we're not going this way. This is not a 90-degree angle, so we have to go straight down this way, and that'll create, and again, extending that side with that obtuse triangle. Then this is where it gets a little different. When we go to the next vertex, okay, the last vertex that we haven't done yet, if we go straight to the other side perpendicularly, we're going to notice here that our 90-degree angle is actually on the inside because we have to be perpendicular, but we extend that line upward, we're going to notice it's going to intersect with this altitude and with this altitude. And that's where we come up with our orthocenter being on the outside of our obtuse triangle. So your orthocenters, you've got one right here for your, draw little arrows, okay? Orthocenter for our obtuse is right here. And then our orthocenter for our right triangle, draw a big old squiggly line pointing right here. So the location of your orthocenter with your altitude will depend on which kind of triangle you have.